So yeah, like a year ago, I thought of why not try to submit a talk for AI Fern, and then like a couple of weeks ago, I got the answer that I was allowed to speak about teaching AI to hunt for vulnerabilities. So then I started with my project. So it's very still in the proof of concept phase, but I think I have quite a lot of funny things to show you. Um, then again, I also named it Teaching AI, and apparently that's a thing in AI. So I hope you don't expect things of me telling you how to teach AI. So bear with me. But before we start, I'm Roald Nefs, CTO at WarpNet, cybersecurity company in Haren. But besides Haren, I also do quite a lot for the cybersecurity community. I'm board member at Stichting Friendly Cyber, where we help organize events such as Besides Amsterdam, which is next week, Besides Groningen, which will be in April next year, and we have a quarterly meetup for Cloud Native Groningen. Uh, in my spare time, if I have still spare time left, I do quite a lot of hardware hacking. So, for example, I hack cars and I present about that on Pygrunn. Um, I will show a couple of code snippets if we have more than enough time. Otherwise, you can also find them on GitHub. Bear with me, I just pushed them yesterday, so still might need to refactor some of them, and I will have to add the slides. And for every talk you do about cybersecurity, you also have to do some kind of disclaimer. I have to tell you that this is for educational and research purposes only. I think you will know. So, cybersecurity. From WarpNet, we do quite a lot of things in cybersecurity. About half of the colleagues are actively pen testing software. And we come across quite a lot of AI-generated code nowadays, which is like a fun business for us because that also means that we come across new types of vulnerabilities, more code. So that's interesting. But me as a CTO, I also have to think about new technologies, and one of them is AI, and how can we incorporate AI within our working practice. So the best thing to do, in my opinion, is to use it yourself. So I went on a venture to try to use AI in some parts of our daily work. So if we take a closer look at pen testing, it's like a totally phased type of work. We start with some information gathering. You do some vulnerability identification. If you see a possible vulnerability, you try to exploit it. If you exploit it, you have to prove that you can maintain access or gain more access. And then you have to make some kind of assessment of the impact towards a client to tell them how to improve their system or their code. So if you look at this loop of pen testing, the question is how can we do something with AI in that part? So a couple months ago, I went to Mark's talk, and I learned that you can do quite a lot of things with coding using AI. And also a term I keep coming across is vibe coding. So basically, you can ask AI to create a contact form. It will generate an implementation, and then you ask it to improve something more, so add form validation, and then hopefully it's ready for integration, which is nice. I don't think it's anything new. If you take a product owner or project manager, he or she is doing this for years, just asking a developer to create a contact form and telling them that there was another unknown requirement later on in the project. But this is just normal type of work. You ask something else to do the work for you. So I think you can do that for pen testing as well. So why not just ask an AI to do a security assessment of a specific target? Then if anything goes well, it will execute some initial security assessment. And then you have to tell it to improve a little bit more because it did something wrong or used the wrong tools. And you have to tell it that you actually want some user records, for example. And then the exploit should be ready for misuse. So that's the idea. And when I was looking around, I actually found a couple of real-world examples, or actually examples of misuse by criminals, which are exactly doing the same thing. So in the threat intelligence report by Anthropic, which was released in August, they actually show how Cloud Code is being misused for criminal purposes. And they have like very detailed prompts showing what the criminals are inputting to the LLM to do some actual exploiting stuff. And the funny thing is, in this case, the threat actor used Cloud Code in Kali Linux, like a known Linux distribution for hackers, and as some kind of attacking platform. So it got access to all the tools on Kali Linux, and off it went hacking companies. And it did very well. Later on in the report, they even show examples that after they were able to exploit companies or systems, the AI was helping them get the most ransom out of it. So telling them on what time period they should get contact again with the client and how much money to ask. So it's quite a nice report. It tells me two things. You can do this on a technical basis, and why is Claude able to see all the prompts of a criminal? Is it able to see my prompts of a normal user? So that's something I'm thinking about as a cybersecurity specialist. But then again, what if I give an LLM access to my Kali Linux machine and see what's going to happen? So then the project started, and we had quite a lot of discussion in the office, because are you allowed to let an AI do bad shit? And don't you need to guide it somehow? So it's like one of my colleagues thought it's like a truffle pig. It's very good at finding truffles, but only if you learn to search for it and you help it guide through the woods, and you end up picking up the truffles to make sure it doesn't only find them, but you also can use and sell them. So meet Truffler, or autonomous pen testing tool using AI. So about the project, I have a couple of requirements for my proof of concept. It needs to be fully local. So I'm not willing to use any LLMs on the internet. I want to run it on my own system. So it's like very isolated. I have full control of the system, and I also can know for sure that it's not leaking any client data to the outside world. It should be in a sandbox execution environment. I don't know about you, but if you give shell access to an AI on your laptop, hopefully you can do your work tomorrow. So I'm trying to do that in a VM. It should be resource efficient because it runs on my laptop, and it should be, you have to think about the resource users, so to say. And I want to integrate a big knowledge base, because that's how we work as pen testers. We come across new things, then we document how we were able to hack it, or what new information we found. And that's how we can also train or tell the AI to use that information as well, to just reenact what one of my colleagues has already done in a previous pen test. So for the proof of concept, I'm not going to take the full pen test process. You have like this from the planning towards the final pen test report of the client. The thing I want to do for the proof of concept, because we already know it can write good reports, so to say, I want to make sure that it can do some actual attacks. So make sure it breaks something. And then later on, if I'm able to work on a newer revision of this project, we can work on making a final pen test report, which is actually readable by a client. So to do that, we need some building blocks to get started. And first of all, on a very high level, what I'm trying to do, I'm using Olama as an LLM server on my MacBook. So everything is running on my MacBook. Came across LangChain, which is apparently a very popular framework, and I know a little bit of Python, so very useful for me. And I'm doing everything in Python, so I also have a reason to submit a talk for Pygrunn next year. So then you have my MacBook, which is running the LLM server. It does that very well on MacBooks if I compare it to my colleagues who are using Windows laptops. Then we have like the Kali Linux VM, and that is where I want to run all the agents, or at least give it access to all the tools. And the tools itself are just the Linux tools available on Kali Linux. So like give it shell access, give it access to nmap, give it access to other SQL injection tools, for example. And because I'm running things locally, it are very small models, we have to add some extra information about hacking and trying to use a vector database for that. And that's where all the blog posts, knowledge database of my colleagues come in. So they should be able to input more and more data, explain my agents how to hack certain things. But the key thing is I want to split it up in smaller parts. So if you then go to the agent part, for me, when I started, what is an agent? It's simply an LLM able to access a tool, and using that tool, it can generate a new response. So that's nice. In LangChain, you can do it in like, I think 10 or 20 lines of Python. And then you have, in my case, a local model on my laptop being able to do things on a shell, which is very fun, because if you ask it to delete the root partition or the root file system, and you just give it enough permissions, it will happily help you out deleting all your files. So make sure to commit often if you want your project to keep alive, so to say. But then again, you give it access to tools such as shell, especially in the beginning, in the research phase. I don't want to let it go in the open world and just do random stuff, especially if I'm able to convince it to hack stuff. So we have to build something in, like a human-in-the-loop system, to make sure we at least can approve, edit, or reject calls, which is very easy to do as well. So you just add like 5 extra lines of code. And then you have like a system where you can interrupt on a tool call, and you can tell it whether or not you approve that it's trying to execute the SQL injection, or you want to edit, for example, tell it that it should use a different target instead of the one it found itself. But the whole thing stays the same. Later on, if you want to make it fully autonomous, you should be able to let it go on its own. But especially in the beginning, I'm still amazed by the fact that it tries different tools. It tries executing SQL injections using curl, for example. Just amazed by what it's trying to do locally. But then again, it's running on my MacBook. It's able to run models, but it's not very good at running bigger models. So we have to split it up somehow. So I'm actually going the multi-agent system way to break it up in smaller tasks. So we have like one agent who rules all tool agents, and then we make smaller tool agents which are specialized in, for example, using nmap, so to say. And then you can combine it with the knowledge it needs for running an nmap scan, and you have like one supervisor or the pen test manager to tell the juniors what they should be doing that day. And you have like very nice copy and pastable architectures for how you can do this multi-agent setup in just the official LangChain documentation. And I just picked one. I went for the plan and execute one because it looked nice. So still willing to try other architectures, but so far it's doing very well. In this case, for the plan and execute style, what you do is you have like one agent which is a planner, and it will split up the task, pen testing a system, into smaller steps. So it will actually make a plan for you with step 1, try to open the target in your web browser to make sure it's reachable. Step 2, use a tool to scan for other services on the same system, for example. And you tell in the prompt that at least step 8 should be very clear, because step 1, or the first step, will be executed by one of the task agents. And the task agents are the ones with access to the tools, and they will use the tools, or at least you have to tell them to use tools, especially for some models. If you don't tell them to use tools, they will try to do it without. and they will be convinced that they found the answer for you. But if you tell them to use tools, it will use tools to do like a SQL injection to try and reach the web service, add more information about it. And then you send it to a replanner, and the replanner is usually the same prompt as the planner, but you add like an extra step that it needs to check whether or not the objective has been reached. So have we fully exploited the target, or are there still steps left? And with the newly found observations by the task agent, do we need to replan something? So what would be the next step if we have this new information about whether or not a SQL injection is able to succeed? But then again, like you have smaller models which are very good at doing smaller tasks. They apparently don't know a lot about Kali Linux, so they will try to do everything in curl. So they will try to do SQL injections in curl. It knows about the SQL injection, but it tries to do it with curl, and it writes local files. So you have to add some extra information. So that's where the vector database comes in. And because we have like a big internal knowledge base, we can just use that to collect some extra information, add some extra information in the context of the agent to execute, for example, the mmap scan or use SQL map. So then you end up with one bigger architecture of the tool itself, which looks something like this. So you still see the task and execute style architecture, but I added a couple of extra steps. I don't know about whether or not you have ever seen a pen test report, but what a pen tester will actually do when he starts and he knows his scope, he will just kick off a couple of tools, which are always the same. If you know it's a web service, you will always use a certain type of tool to do the initial scanning while you're still clicking through the application. I don't need an agent to do that for me. I can just, in the discovery phase, script and automate a couple of those tasks, which makes it easier for the planner to make a concise and good plan instead of just random stuff in a plan. So, for example, in a discovery phase, I can already do an mmap scan or network scan on the target the moment I know the target. And that can be very useful for the planner if it knows whether or not it's a web service, if there are any other ports which need to be tested. So it doesn't need to think about that for itself. And then again, you have, the thing I found, if you have quite a lot of smaller tool agents which with their own vector database and their own tools, it's very hard for the planner in a small model to find the correct agent to do so. So you can just make like some supervisor agent which knows which tool agents it has available, and then it can take the first step out of the pentest plan, and it will find the best tool agent to do the task with. Just an extra step, making it easier to run it on a local, smaller model. And then the replanning step is the same. Funny thing is, if you want to do pen testing stuff with LLMs, and there are by default some safeguards in it to prevent you to do bad stuff with it, you have to convince it to do pen testing part. But if you tell it you're doing it ethical, most of the models will be happily help you out with your pen testing part. But then again, there are still some risks, and this is also the reason why we are not using this for any of our client application, but just in a sandbox environment, because there's still quite a lot of uncontrolled behavior. The agents can decide for themselves that the next step will be something that's not in the initial scope, and then that might actually cause a lawsuit, so to say, if it went on and thinks you have to target like AI.nl instead of the target we give it. There might also be some data exfiltration or leakage. If the AI thinks it needs to send some data to a random API on the internet, it will just do so. So if you're not fully sure that your application you're testing or your system you're testing doesn't include any sensitive data, you shouldn't be running this in the wild. And the funny thing, if you ask a hacker to take a look at my proof of concept, the first thing it will think is how can I break this proof of concept of Roald? So many of my colleagues already went on the full path. Okay, I will give you a target, and I will try to do on that web page, I will try to convince your AI agent to take a different scope. So they will try to do prompt injection or model manipulation on the target itself. So also a reason why you should be very sure it works. And there's always a risk in human oversight. So during a pen test, the pen tester has like his own judgment to tell whether or not he or she should continue to pen test or stop and escalate and communicate with the client. The agent will just continue. If it breaks stuff, then yay, it won, and it will try to break the next thing. So it just continues. And as long as we are not fully sure what it's going to do next, then you need to make sure there is some human oversight in it. And I think Mark already explained it quite nicely. Adding some extra logs will definitely help to figure out what it has done so far. And it's also very nice to then end up being able to follow the same path as the AI agent did to break a service. So some things to mitigate those risks, which we still need to work on before we allow it to use by anyone else, is that we have to define strict guardrails. So we have to make sure we find a way to enforce the scope. We have to make sure that it is rate limiting. So it's not trying to pull down services by just doing it very hard, so to say. Some domain whitelisting, so make sure that it's only allowed to scan certain domains. And building kill switches. If we see it doing something wrong, that we have like a switch we can press so it stops. We want to keep a human in the loop. So especially in the beginning, if it finds something, just ask for approval. It will take a little bit longer, but especially then we know what it's trying to do. We are trying to isolate it, run it in a controlled sandboxed environment. So don't give it access to the internet. Don't give it access to your own system. Make sure it can, if it breaks something, you're still able to recover from that until you know for very, very sure that it's not going to leak any sensitive data. Log everything. So make sure you can trace back all the steps it took, which is also a requirement for us doing a pen test, because we also have to explain to the client how we broke their system and how they can improve on that, or tell them what we did or didn't do. And it's always important to validate the output. Like I told, the local models I've been running so far are very convinced. Sometimes they found a SQL injection, but they just ran out of things with their curl SQL injection so far, and then they will just come up like active as if they found a SQL injection and continue from there, because the replanner also thinks that was a nice observation and will just continue from downwards from that. So we have like a little bit time left, and it's always very risky, especially if you have AI to do live demos, but why not give it a little try? And then we have multiple screens. So in the project, you will find smaller examples, and combine them together. You have like the same thing in our proof of concept. But in this case, we have like a small agent. But just to show you, it's running on my LLM server on my MacBook, and we will ask it the weather in Gun. And it does a tool call to a Python function which says it's always rainy, which is correct today. And then it makes a joke about it. But it just shows that in like 10 lines of code, we're able to do a tool call. Let me find the correct window. Live demos are always nice, so bear with me. So let's show some code. In this case, we are going to look at the plan and execute style thing, just to make sure you all recognize it's quite easy to do yourself. Don't look at the way I typed it. I just copied and pasted from the LangChain documentation. But in this case, we have like our imports. We are using GPT-OSS, the 20 billion thingy on or LLM server on Llama, and we added like a simple function which always says that it's rainy in a certain city, and then we define like the actually task agent. So in this case, you can tell it you have you're a helpful assistant. You have to tell this model that it should use tools, otherwise it's just trying without it. It gets access to the get weather tool. Then you have some extra things. Most interesting part in this case, the planner prompt. So you have like a very small prompt which tells that it should create a simple step-by-step plan for the works to execute. The nice thing, what we're doing in Truffler or pen testing tool, so to say, is that in the end of this prompt, we will add like the things we found in the discovery phase. So the output of the mmap scan, we just added to the context. This is what we already know about the target, and then just put our stuff in there so it can make a better plan. And then we have like the prompt, the additional prompt for the replanner. So it will get the original objective. We tell it what the original plan was and what the workers have found so far. And then we tell it should update the plan accordingly, and only if it reaches the objective, it can return to the user. But like this example is with a couple of comments within 200 lines of code. It should be quite easy to do this like in the afternoon. I was able to do this on a Sunday afternoon. And then for the actual demo, let's find the correct one. Is it there, or did it remove itself? What is happening? Oh, yeah. It's always hard if you aren't able to type and you have to look on the back. Should have thought about this when preparing, setting up the screen. Sorry for that. Okay. So it's now running. So first, it will generate a plan. So the planner gets the same task of telling the weather in Gun. It made the plan. It broke it up in smaller steps. So you will see like a list. And then it will give one of the tasks to one of the workers, so to say. And it just tries to keep repeating till it found the objective. And this goes on and on till it finds like it does a tool call. It has like it tells you the rainy weather. But you should imagine that if you ask it to generate a pentest plan, and what I can show you is at least prompts, because it takes way too long to run the demo itself. But I can show some of the prompts. So bear with me, this is still all work in progress. But here you see like the initial prompt. So you're, as a penetration testing expert, your role is to help identify potential vulnerabilities in a system or network. Blah, blah, blah. You have some rules. Perform a penetration test on a specific target. If you find a web server, you should focus on it. Nice thing to know. We try to focus on web servers doing pen tests because that's what a client sees. That's most often publicly facing. There's also quite a lot of knowledge about that. Quite a lot of our colleagues are writing about cross-site scripting, such things like that. So our knowledge base has more information about that part. So more interesting for our proof of concept. Do not perform a full port enumeration or try to brute force things because it will try to do so, because there's quite a lot of apparently things it can try on that way, and prior discovered information, which is just like the output of the mmap scan. And like the worker and like the planner are just like the same prompts you've seen in the previous architecture. So for the future, or actually more about Truffler, you can compare it now with the first day intern pen tester at WarpNet. So we have like interns willing to do pen testing stuff. They know how pen testing works. They know how to open Kali Linux, and they just start tinkering with it and pushing random buttons. I think we will end up being able to reach the level of a junior pen tester, but nowhere close of a senior. But that's my small presentation with a very bad demo. If there are any questions, please let me know. I will try to actively post on LinkedIn about the progress if we are able to reach it on a certain level that we can actually share the code with you. So are there any questions?
Applause first, I think.